Right? I think you have drawn the figure, but I'm not going to erase it. I'm not going to erase it. Look at board there. Listen, I am going to draw a velocity time graph for this motion. For the velocity, let me use the letter V. For the time, let me use the letter T. And when you draw a graph, whenever you draw a graph, you must indicate the units. Right. So during the first 200 seconds, velocity is constant. During the first 200 seconds, velocity is constant. So this is how we represent it. During the first 200 seconds, velocity is 20 meter per second. It is constant. During the next 20 seconds, velocity increases from 20 to 30. So it's an acceleration. Within the next 20 seconds, velocity increases from 20 to 30. So it's an acceleration. So acceleration can be represented by a straight line like this. So velocity increases to 30 within the next 20 seconds. So T2 is 20 seconds. Then within the next 200 seconds, velocity is constant. Velocity is constant within the next 200 seconds. That is 30. Right? So this time duration T3, that is 200 seconds. That is 200 seconds. Within the final 30 seconds, the object decelerates and comes to rest. So this is finally 30 seconds. So this is the complete velocity time graph. Velocity here is 0. Draw the graph. I want to mark some points to describe the motion. I mean, sometimes you have to find the area also. So I put some. I'll mark some points on the graph. Draw the velocity time graph here. Let me take this point as A, this as B, this as C. I think you will be confused. Okay, let me use this as P. This is Q. This is R. This is S. Can you see everything there? Can you see everything properly? No, you can't see S. You can't see S. So what can I do? I move the cam like this. Can you see S now? Namai, can you see the letter S now?
Yes, sir.
Yes, sir.
Right, now S is visible, right? Okay. So I want PQRS. Then I need some other letters also. And let me mark this points as R. This is as T and T dash. T dash. R T dash. And here, let me mark this point as S dash. Can you understand? PQR S dash T dash. Mark them here. So we will need these letters: constant velocity, acceleration, constant velocity, deceleration. T dash, S dash. And finally, let me take this as X, Y, Z. X, Y, Z. Perfect. Draw the graph, mark all the points. Right, Lamai. So how do you find the acceleration here? They ask you to find the acceleration. We can draw the displacement line graph later. So let me mark this angle as alpha. And somebody please tell me, Lamai, somebody please tell me what this height is. What is this height, Lamai?
30.
30, very good. So this is 30. If this is 30, so what is this height?
20.
This is 20, right? This is 20, this is 30. Therefore, what should be this height?
10.
This is 10. So 20 plus 10 is 30. If this is 10, what is this height?
10.
10.
That's also 10.
What is this length? This
20.
length?
20.
This is 20. 20 means T to 20. So this is 20, right? So then how do you find acceleration then? What is acceleration? Acceleration is Lamai tan alpha.
Tan alpha.
So tan alpha means acceleration is tan alpha. Tan alpha means opposite side, that is P dash divided by adjacent side, that is RP dash. RP dash. Can you find the acceleration and send your answer to my Zoom chat there? Write this, find this acceleration, send your answer to my Zoom chat. Start. Right, very good. Many of you have sent the correct answers. T dash is 10. RT dash is 20, 0, 0 cancelled out, half. So 1 over 2 means 0.10 divided by 2 is 5. 0.5 meter per square seconds. Who got this answer? Raise your hand up. Lamai? Okay, nice. Great. Then we want to find the total displacement. How do we find the total displacement here? Lamai? A velocity time graph is given. We want to find the displacement. What should we do?
Area under the graph.
Area under the graph. Very good. So I'm going to erase this figure. I have to erase this figure. Right? So I erase the figure and I'm going to write total displacement equals area under the graph. That's what I'm going to do. Right. Right. Look at board. Right, look at board here. So total displacement. Total displacement is area under the graph. Actually, you can identify several sections here. First, you have a rectangular section of PQRS. So you should find the area of PQRS plus. Then you have a triangle, that is RPT dash. Then you have a triangle of RPT dash. triangle. And you have another rectangle. What is this rectangle here? R T dash S, like this. R S S dash T dash. R S S dash T dash. R S S dash T dash. After that, you have a very big rectangle. What is it here? T S dash Y X. T S dash Y X. Finally, you have a triangle that is X Y Z triangle. Can you find the total displacement by using this? You will try, find the displacement, send your answer to my Zoom chat. Try here. Once you find the area, once you find this displacement, send your answer to my Zoom chat there. Right here, I think you don't want my help. Okay, some students have obtained the answer. Let me check. PQRS, it's a rectangle. Area of a rectangle is length into width. Length is 200. Length into width, right? So that is PQ into, PS. Length is PS. Width is PQ. Plus area of RT dash T, RT dash, it's a triangle. Area is half into base into perpendicular height. That is T dash T is the perpendicular height. T dash T is the perpendicular height. PQRS triangle RS S dash T dash. RS S dash T dash is a rectangle. Area of a rectangle is S dash, length into width, that is SR. Plus, then you have a triangle. T S dash YX. T S dash YX. So length of a rectangle is S dash Y length into width. Width is S dash T. S dash T. S dash Y. Then again we have a triangle. Half into base is YZ into perpendicular height YX. Check whether you have written the things like this. First, you have identified the sections of the graphs. Otherwise, it will be difficult. Right? Some of the students have already sent me the answers. Right. PS is 200. PQ is 20. PS 200. PQ is 20. 20 into 200. Plus half. RT dash is 20. T dash T is 10. Plus S dash. S dash, that is 20 into SR. SR is also 20. S dash 20, SR is also 20. Plus S dash Y, that is 200. S dash Y, that is 200. Into YX. S dash T. S dash T is 30. This is 30, you see. This is 30. 30. So S dash T is 30. This is 30 plus half YZ. YZ is 30. YX again 30. See the beauty? This all the things you come here, that is 30. Right. Check whether you have written all the steps properly. Check whether you have written all these steps properly. Lamai. Right. So finally, look at board. So simple. 0, 0, 0. Just write the 3 zeros. 2 times 2, 4. 1, 2, 3 zeros. 2 times 2, 4. Plus 20 divided by 2. 20 divided by 2 is 10. 10 times 10, 100. 20 divided by 2 is 10. 10 into 10, 100. Plus 20 times 20, 400. 20 times 20, 400. Plus 200 into 30. 0, 0, 0. 1, 2, 3. 3 times 2, 6,000. Plus 30 into 30. 30 into 30, 900. Divided by 2. Half into 900 is 450. Or 900 divided by 2. Now you see, we can easily add 4,000 plus 6,000. 4,000 plus 6,000, 10,000. 10,000 plus 400, 10,400. 10,400 plus 100, 10,500. 10,500 plus 450 means 10,950. So total displacement is 10,950 meter. Who got this answer? Lamai, who got this answer? Please raise your hand up. Say the way I have added the numbers. 4,000 plus 6,000, 10,000. 10,000 plus 400, 10,400. 10,400 plus 100, 10,500. 10,500 plus 450 is 10,950. Okay. Right. So now we know the total displacement. How do you find the average speed here? Average speed to average displacement, because the motion is along a straight line path. How do you find the average speed to average displacement? Average velocity or average speed is equal to total displacement divided by total time. This is the equation. How do you find average speed or average displacement velocity here? Divide the total displacement by total time taken. The total displacement is 10,950. Total time taken is 200 plus 20 plus 200 plus 30. 200 plus 20 plus another 200 plus 30. So that is 10,950 divided by 200 plus 200, 400, 430 plus 20 is 450. Can somebody divide and give me the final answer? Your right zeros can be cancelled out. What is this here?
$24.
10,950 divided by 450. Somebody please tell me this. Lamai?
24.33, sir.
Very good. This is 24.33 meters per second. Who got this answer also? Please raise your hand up if you got this answer. Lamai? Right. So next time we can draw the displacement time graph. Right. it tells us during the first 200 seconds, the vehicle travels with the constant velocity of 20 meter per second, right? The vehicle travels, or the vehicle or any object, it travels a certain distance with a constant velocity during the first 200 seconds. After that, it accelerates and velocity increases up to 30 meter per second. So initial velocity 20, final velocity 30. It accelerates for a period of 200 seconds. We were disconnected here. Lamai, did we disconnect? Did you hear the things that I have said? Hello, can you hear me, dear?
No,
No, sir.
sir, we didn't.
Okay, I was drawing the velocity time graph. Actually, I was right. Listen to me. So I was explaining the graph, right? I didn't know that we were disconnected. I was explaining the graph. I didn't know that we were disconnected, right? Isn't it? The vehicle travels with a constant velocity of 20 for a period of 200 seconds. During the next 20 seconds, it accelerates, velocity increases from 20 to 30 within the next 20 seconds. Within the next 200 seconds, the vehicle travels with a velocity of 30 meter per second. We have already drawn this graph. And during the final 30 seconds, the vehicle decelerates and comes to rest. So this is the graph, right? This is T1, T2, this is T3, T4 is 30 seconds. We have already drawn this graph, whether even you didn't hear me, it's okay, right? Because we have drawn. This is 0, right? My question is, if this is 0, if this is 20, what should be this height? Namai, what should be this height?
20, sir.
20, very good. If this is 0, if this is 30, what should be this height?
30, sir.
30. If it is 30, what should be this height? What should be this height here? 0, 30, and you see the same line. So therefore, what should be this height? I have asked what I think you didn't hear my question. I have asked what this height is. I think due to the poor network connection, you didn't hear me. I asked you to tell me what this height is. Somebody?
Thirty.
Yeah, very good. Is my voice lacking or can you hear me properly?
Lagging, sir.
Right. This is the question that we stopped last week. Last week we stopped with this question under the graph section, right? So it tells us in question number 96, it tells us 600 questions due. It tells us an object travels first 200 seconds with the constant velocity of 20. Within the next 20, within next 20 seconds, the velocity increases from 20 to 30. So there's an acceleration. After that, the vehicle travels with the obtained velocity of 30 meters per second for a period of 200 seconds. And finally, during the last 30 seconds of time period, the object comes to rest. So what kind of motion is this there? Constant velocity, acceleration, constant velocity, and deceleration. Right? So if this is 0, this is 0 to 20, 20 height. If this is 0, this is 30, therefore this height is 30. If this height is 30, this should also be 30. Am I right? And if I mark this angle as alpha, I can find tan alpha is equal to the acceleration. From a velocity type graph, gradient is the acceleration. If I mark this angle as beta, I can find the deceleration. So if this is 30, this should also be 30, right? So both should be 30 each. 30 and this is 30, so you can find the deceleration. Here you can find the acceleration. If this is 20, this should be 20. And if this is 30, this is 20. So it means this height is 20. So this should be 10. It should be 10, right? So this is what we have already discussed. I have just drawn it for you to recall your memory about the question. Here we want to draw the displacement time graph. We have answered all the things of this question, but we did not complete the displacement time graph. So here we have, this is constant velocity, this is constant acceleration, this is again constant velocity, and this is constant deceleration, right? So you can use any letters to indicate the motion. If you have not drawn this graph, I'll give you about 5 minutes, draw this. If you have not drawn this graph, okay, if you have not drawn this graph, please draw it there. So if you have not drawn this graph, please quickly draw it. I'll give you 5 minutes. Right, I think time is enough for you to draw this velocity time graph. I gave that time to some of the students who were not able to draw it that time. So can you hear me properly before I start the explanations? Could you please tell me whether you are able to hear me clearly or not?
Yes, sir.
Right. Thank you, dear. Now listen, dear. So during the first 200 seconds, it travels with the constant velocity. How do we represent constant velocity in a displacement time graph? So now we are going to a displacement time graph, right? So time is indicated by simple T. Displacement is indicated by S. Unit is meter. So sometimes people may use the term ST graphs. For the velocity time graph, sometimes people may use ST graphs, right? So because we use S for velocity, S for displacement. So that's why some people use the term ST graphs, right? So during the first 200 seconds, the object travels with a constant velocity. Constant velocity is indicated like this in the ST graph. So let me mark the time as 200. If you want, you can find the displacement here, right? If you want, you can find the displacement S1 from this graph. From velocity time graph, how do you find the displacement? Just take the area under the graph. For a velocity time graph, area under the graph is the displacement. So you can easily find this S1 if you want. Then during the next 20 seconds, there's an acceleration. So in a velocity time graph, acceleration is indicated by a straight line. In the velocity time graph, acceleration is indicated by a straight line. In the displacement time graph, acceleration is indicated by a curve like this, right? So then it obtain displacement of S2, right? This is during the next 20 seconds. During next 200 seconds, the object travels again with the constant velocity. So constant velocity is indicated like this. Constant velocity is indicated like this. So this is what happened during the next 200 seconds, and finally it decelerates and comes to rest. So deceleration indicates like this. Deceleration is indicated like this kind of a curve. So this is what happened during the last 30 seconds, but I will explain further. I give you more descriptions about displacement time graph. First you complete this answer. After that I'll give you more descriptions, more explanations, right? This is the displacement time graph for this velocity time graph. Completed here? So if you want, you can calculate this S1, S2, S3, S4 easily from this velocity time graph. That's just area under the graph. Draw it. Right, is the time enough for you to draw the graph here? Who wants any more time to draw this graph? Amoy? Right. So in a velocity time graph, this is how we represent constant velocity. In a displacement time graph, constant velocity represented in a different way. So that's what I am going to explain today. In a velocity time graph, acceleration is represented by a straight line like this, an inclined straight line like this. But in a displacement time graph, acceleration is a curve. Right? This is constant velocity, this is deceleration. So I am going to give a note about these shapes: constant velocity, acceleration, and deceleration. So that's what I'm going to do next. So please check when you have drawn all the things. If you have drawn all these things, I can I'll erase these things and I'll explain these shapes. You need my help to understand these shapes here. If you have drawn all these things, send a message to my Zoom chat saying done. Then I'll explain everything. Okay, dear? Am I? Right, I think time is enough. Look at board here. So you should identify 6 different shapes for the graphs lesson team. I'm going to give you those 6 different shapes, and we can prove all these shapes also. Right? For the graphs lesson, you should remember 6 different shapes. Actually, you have learned those things even in O levels. The problem is you have forgotten them now. You have learned those shapes in your O levels. Unfortunately, you have forgotten them, right? Therefore, I should recall your memory by giving those shapes. Look at board here. Actually, there are three different kinds of motions you should that you want to remember. There are three different kinds of motion. You should remember those motions. The first kind is the constant velocity. So I'm going to give you the shapes as a summary, right? If you do not remember this these shapes, or still you are confused with these shapes, so I can arrange another day to explain the shapes of these graphs. The first thing that you should remember is constant velocity. Constant velocity. How do you represent constant velocity in a velocity time graph? That's the graph that we have learned last week. In a velocity time graph, it's so simple to explain, represent constant velocity. Just a straight line like this. How do you represent the same motion when an object is moving with the constant velocity? This is how we represent its motion in the velocity time graph. How do you represent the same motion in a displacement time graph? For the displacement, let me use the letter S. For the velocity, for the time, use simple T, right? So in a displacement time graph, the constant velocity is indicated something like this. And look at both. If I mark this angle as theta, from a velocity time graph, the gradient of a displacement time graph. The gradient of a displacement time graph is equal to the velocity. Right? This is what you want to remember. So therefore, velocity equals gradient means tan theta. Tan theta. That's it. So two different graphs, two different shapes. For a velocity time graph, this is constant velocity. The constant velocity is represented in a displacement time graph like this. You have learned all these things even in O levels, but if you do not remember or if you are confused with this, send a message to my WhatsApp. I can arrange another day to teach these things. Right. Please draw. This is the summary number 1. Like that, we are going to draw 2 more graphs, 2 more sections. So one section has 2 graphs, 3 sections. There will be 6 graphs. You have to remember the 6 shapes. And I'm going to explain those 6 shapes, 6 different graphs by doing some questions. That's what I'm going to do. Right. Draw them there quick. Start saying summary. Here, S4 displacement, right? We have used the letter S4 displacement. Right. The second kind of the thing is constant acceleration. How do we represent constant acceleration in a velocity time graph? Right? Velocity time graph, V for velocity, T for time. And how do you represent constant acceleration in a displacement time graph? T for time, S for displacement. So this is what we are going to learn next. Summary number 2. First you complete summary number 1. Right, constant acceleration represented in a velocity time graph like this. If I mark this angle as alpha, what is tan alpha here? Tan alpha is the gradient of a velocity time graph. So look at board here. Gradient of a velocity time graph. What is it here? Two different graphs, two different things. That's the point. The gradient of a displacement time graph is velocity. The gradient of a velocity time graph is acceleration. That's what you will do. That is acceleration. Okay. So if I want to find the acceleration, I should find tan alpha. So that's how we find. In a displacement time graph, acceleration is represented in a different way. Acceleration is represented like this, right? Velocity time graph, this is how we represent constant acceleration. Displacement time graph, this is how we represent constant acceleration. The gradient of this velocity time graph is acceleration. Therefore, if you find tan alpha, that is equal to acceleration. Got it? Completed here. So two different graphs, two different meanings, right? Right, I think you have drawn them. Now, somebody please tell me how to find the displacement from a velocity time graph. How do you find the displacement from a velocity time graph? Lamai?
Area under the graph.
Very good. So displacement, very good. So displacement equals area under a velocity time graph. Area under a velocity time graph. Displacement is area under velocity time graph. That's it. Complete this note. This is the summary number 2. I'm going to draw 2 more graphs. We are going to use all the 6 graphs to solve the problems. Once we solve some problems, you will be okay with the lesson. Start here. Right, the third and last two graphs, the third set. Look at board. How do you represent constant deceleration? Constant deceleration in a velocity time graph. How do you represent constant deceleration in a velocity time graph, and how do you represent the same constant deceleration in a displacement time graph? That's what we are going to learn. Can you draw them without my help here? Do you remember your past? Check that you remember the constant deceleration shape in velocity time graph and constant deceleration shape in displacement time graph. You were trying to draw them before I draw them. You were trying. Constant deceleration. Constant deceleration. In a velocity time graph, constant deceleration is represented like this. In displacement time graph, constant deceleration is represented like this. Curve bent to this direction. And look at board. If you find this angle, here we can't say gradient, as people know the reason. If you find tan beta, right? So this is how we represent constant deceleration in a velocity time graph. If you find tan beta is equal to Lamai.
Deceleration.
Deceleration, very good. So still the relationship is true. So deceleration. Sorry. Deceleration equals tan beta. What about displacement here? Displacement is whether it is constant velocity, constant acceleration, or constant deceleration, whatever it is, velocity displacement is always equal to area under the graph. So displacement is always equal to area under the graph. Area under the graph. Complete this here, quick. So this is the third set of the summary. We have 6 graphs. We have drawn 6 graphs. We are going to use those 6 graphs to solve problems. Complete.